Hi everyone, my name is Miss Hu and I am a physics teacher. In this video, I'm going to go through an overview about scalar and vector quantities. Now I'm using the Jamboard because I'm actually a whiteboard kind of teacher. It's just that because this is a digital recording, I can't actually use a whiteboard. You won't be able to see what I've written. So I decided to use a digital whiteboard instead, which is the Jamboard. Now, let's start. So as you should have already learned in an earlier lesson, physical quantities are quantities that can be measured. And we already know physical quantities can be divided into two categories of base and derived quantities. This is another way to divide physical quantities. This is another set of categories, and you can divide it into scalar and vector. Now, what is the difference? Scalar quantities are quantities with magnitude only. Vector quantities, on the other hand, have both magnitude as well as direction. Now, before we go on to the next slide, I'd like you to watch this clip. I'm sure that many of you have already watched this before. It's from a really popular animated film, and I really enjoyed this show, and I hope you did. So anyway, let's just watch this clip.
Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah! Check out my new weapon. Piranha gun! Oh yes! Fires live piranhas. Ever seen one before? No, you haven't. I invented it. Do you want a demonstration? Oh! Ah! Gosh, it's so difficult sometimes to get the piranha back inside of my...
So if you had watched this before you learned physics, you're probably like, okay, what did he mean? Probably didn't know, just laughed along and enjoyed the rest of the show. But now that you have learned physics, this should all make sense. Let's go through scalar quantities first. Now, scalar quantities are quantities with magnitude only. If you don't know what magnitude actually means value. So for example, if you express the value of length as 100 meters, the value of 100, that's the magnitude. There are a lot of physical quantities which you have learned so far up to this point in your life. And most of them are scalar quantities. So if you were wondering, how come I've never heard of the term scalar and vector before? It's because you didn't need to. So if you remember your base quantities, all 7 of the base quantities fall under the scalar quantity category. Now, of course, there are a lot more. Just bear in mind that as long as they don't have any directions, those are scalar quantities. So I'm going to write an example here. For example, length, time, temperature, mass, current, even area, volume, speed. These are all quantities which have values. When you measure them, they have magnitudes, but they don't have directions. So if you're wondering, okay, what does this mean? What do directions mean? Let me discuss vector quantities so that you can understand this better. Vector quantities have both magnitude as well as direction. Before I write the example here, let me explain a little bit more so that you have a clearer understanding of what we mean when we say direction. I'm sure that all of you have no problem understanding what magnitude means. Let's use an example that you already are familiar with, which is force. Now, as you know, let me just move this out of the way so that I can get to the polygon. Whoops, my face is still blocking it. Okay, so let's say we have an object that is sitting on a surface like so. Okay, imagine, I know it's not straight, imagine it's straight. This is a surface. And we have forces acting on this object to make it move. So let's say, for example, we have a force pulling it to the right, let's say 10 Newton of force. And you can also have a force pulling here, say 3 Newton. So these two forces are acting in the same direction. But if you have another force pulling it in the opposite direction, say 15 Newton, think about it. If you don't have this 15 Newton force, these two forces are pulling to the right, they're working together. But if you suddenly put in another force of 15 Newton in the opposite direction, they will be fighting each other. So imagine if we don't have this diagram. Say, for example, I just tell you, okay, we have an object where there's 10 Newton, 3 Newton, and 50 Newton force acting on it. What is the total force acting on this object? If you didn't know the directions, you probably would have gotten it wrong. If you added them all up together, that wouldn't be correct, because if we look at the directions of the forces, you can see that some of them are acting opposite to each other. So the force directions are extremely important. In fact, it's even possible for a force to act at a different angle altogether, or even at an angle like this or an angle like this. It's possible. So when it comes to forces, angles are very important in determining how the object will behave, how the force would make the object move. That is why force is considered to be a vector quantity, because the directions are very important. So physical quantities that have directions as an implied part of their nature, those are vector quantities. So examples of vector quantities, let me rewrite the term vector over here. Let's write vector quantities to make it full. So again, remember, vector quantities have magnitude because you can't run away from that, right? Physical quantities must have magnitude. When you measure something, there must be a value. But in addition to the magnitude, vector quantities also have directions. And examples that you need to know of are, of course, force. There's also displacement. There's velocity, acceleration, and many, many more. I will discuss displacement, velocity, and acceleration in a separate video. This video is just to give you an introduction to scalar and vector quantities. So I hope you found this video helpful and educational. Don't forget to click like and hit subscribe if you haven't already subscribed to my YouTube channel, Physics Rocks. Thanks for watching and happy studying.